Welcome to checking solutions and solving IVPs. So for an example, let's consider the differential equation y double prime plus 5y prime plus 4y equals 0. And let's verify that y1 equaling e to the negative x and y2 equaling e to the negative 4x are both solutions to this equation. So let's start off with y1. So if y1 is e to the negative x, then we have y1 prime would be negative e to the negative x, and y1 double prime would be positive e to the negative x. So if we plug this into y double prime plus 5y prime plus 4y equaling 0, I'm going to replace those all with y1s. We want to know if this is true. We are looking at e to the negative x plus 5 times e to the negative x. Sorry, 5 times negative e to the negative x. Plus 4 times e to the negative x. Wanting to know if this is equal to 0. And here, this is just 5e to the negative x minus 5e to the negative x. And so we get 0e to the negative x, which does indeed equal 0. So we get that y1 equaling e to the negative x is a solution. Similarly, if we do this for y2 equaling e to the negative 4x, y2 prime would be negative 4 e to the negative 4x. y2 double prime, we're looking at 16 e to the negative 4x. If we plug this into the equation, we're looking at y2 double prime plus 5y2 prime plus 4y2, wanting to know if that is equal to 0. So we have 16 e to the negative 4x plus 5 times negative 4 e to the negative 4x plus 4 times e to the negative 4x, wanting to know if this is equal to 0. So this becomes 16 minus 20 plus 4 times e to the negative 4x. So we just get 0 e to the negative 4x, which is indeed equal to 0. So we also have y2 equaling e to the negative 4x is a solution. Our next step, we are going to take what is called a linear combination. So this is a linear combination of y1 and y2. So we are going to take some constant c1 multiplied by 1, and then plus some constant c2 multiplied by y2. And we want to verify anything of this form is also a solution. So if we have y equals c1 y1 plus c2 y2, we therefore have y prime is c1 y1 prime plus c2 y2 prime, and y double prime is c1 y1 double prime plus c2 y2 double prime. So now we want to know, does y double prime plus 5y prime plus 4y, does this equal 0? Plugging in, we would be looking at c1 y1 double prime plus C2, Y2 double prime. That's Y double prime. Then we have plus 5 times C1, Y1 prime plus C2, Y2 prime. That's Y prime. And then we have plus 4 times C1, Y1 plus C2, Y2. And we want to know, is this equal to 0? I need to give myself a little more space. We rearrange this, lumping everything multiplied by C1 together. We have sorry about that. We have C1, Y1 double prime plus 5C1, Y prime plus 4C1Y. And then we have Y1 and Y1 for both of those. And then we have all the C2 terms. Updating. We have all of our C1 terms. Then if we do all of our C2 terms, we have C2, Y2 double prime plus 5C2, Y2 prime plus 4C2, Y2. And we want to know if this is equal to 0. Those first three terms, if we factor out a C1, this is Y1 double prime plus 5Y1 prime plus 4Y1. And then the last three terms, if we factor out a C2, we have Y2 double prime plus 5Y2 prime plus 4Y2. This is then questioning if this is equal to 0. Sorry, my screen's not updating. I apologize for all of that back and forth. Hopefully this will work better. So our first component, that C1, Y1 double prime plus 5Y1 prime plus 4Y1, the stuff in parentheses should just equal 0. We actually just check this since Y1 is a solution to the equation. And similarly, that C2 times Y2 prime plus 5Y2 prime plus 4Y2, everything in parentheses there should also equal 0. Again, since Y2 is a solution. So in this case, we do check out, and any linear combination of those two solutions is also a solution. So next thing we're going to do is we're going to solve for a particular solution, satisfying the initial conditions y of 0 equals 5 and y prime of 0 equals -2. So what we're going to do is we are going to assume that y is a linear combination of y1 and y2. We have not yet shown that it must be this, but we are going to operate under that assumption. And so what we have then is y is equal to c1 times e to the -x plus c2 times e to the -4x. So in addition to that, we also have y prime would be -c1 e to the -x minus 4c2 e to the -4x. So now we'll go ahead and plug in. So y of 0 equals 5 would mean that we would have c1 times e to the 0th, or c1 times c1 times e to the 0th plus c2 times e to the 0th, or in other words, 5 is equal to c1 plus c2. Plugging in y prime of 0 equal to -2. We would have -c1 e to the 0th minus 4c2 e to the 0th is equal to -2. Or in other words, -2 is equal to -c1 minus 4c2. So now we need to solve a system of equations. So we are going to solve the system c1 plus c2 equals 5, and -c1 minus 4c2 equals -2. You can solve this system using matrices in linear algebra. You can solve this system by doing just elimination straight with it in this form. You can solve the system by doing substitution. That is entirely up to you. I'm going to do elimination. So if I add these together, c1 minus c1 is just 0. c2 minus 4c2, we would have -3 times c2. And 5 plus -2 or 5 minus 2 would be 3. So we get then that c2 is equal to -1. So c1 plus -1 equals 5 would mean that c1 should be 6. So our final solution, we plug those back in. So our solution, we had y was equal to c1 e to the -x plus c2 e to the -4x. We therefore get y is equal to 6 e to the -x minus e to the -4x. So this is solving a second order IVP if we already know sort of two special solutions.